Good morning, everyone. Welcome to English Medium Prep by Exampur. And I'm Kumar Ravi. I'm here to discuss some more questions on current electricity chapter. Okay. So, guys, you are just watching the India's number one educational channel, and that is Exampur. And this is the new channel for the English medium students. And if you have not subscribed this channel till now, then please do subscribe this channel and share this session among all your friends. Okay. And I would tell you that I come live daily at 10 a.m. in the morning and at 2 p.m. in afternoon. Okay, I teach the theory portion in 2 p.m. session, and I discuss some important questions or the previous year's questions at 10 a.m. morning session. Okay, so guys, let's start and let's start the session. And guys, I would say that please do share this session on your social media account so that the students, those who are preparing for the different government jobs, they can also reach out to us. Okay, so today's topic is today's chapter is current electricity. Okay, yes, today's the chapter is current electricity. So we will discuss current electricity chapters, current electricity problems. So guys, first of all, I would like to tell you that instead of rather than the free batches on YouTube, we have some paid batches also. Okay, so if you are very serious and you want to complete your syllabus step by step from basic to advanced level, then you must join our paid batches. And for the paid batches, you will have to download our official application, and for that you will have to go to the Play Store, and then you will have to type Exampur. Then you will find Exampur Sarkari Nokri Prep. Then download that application, and after downloading the application, just install and then open that application. You will see the two options there. Number one, register or login. Okay, so if you are an old student, okay, then obviously you must have already subscribed or already registered at our database. Okay, so you just need to log in that application. And if you are new and downloaded the application the first time, then you will have to register yourself. So you will have to push the register button, and then you will see a form that has to be filled by you. Name, you will have to enter the name and email ID and mobile number, place, district, examination name, okay, for which you are preparing for. And then you will have to register that, and after registering, just log in again. Okay, you will have to select one password also, so that you can that password you will have to remember. Okay, so after login, you will see there are the many categories in which the batches are running. Okay, but select your batch in which you want to get admitted, and then just see the demo videos, and then you can just join that batch by paying a very small amount of fees. Okay, so in this way, you when you purchase any batch, when you join any batch by paying some amount of the fees, then you will get a live video lectures and the PDFs. Okay, PDF files of the previous year's questions, mock questions, as well as the practice questions, as well as the study material also. Okay, there are many teachers who try to solve all the doubts online also. Okay, so all these facilities you will get just by after paying a very small amount of fees. Okay, so download the application and tell your friends also. And if you are very serious towards your goal, then I'm sure that we will help you to achieve your goal 100%. Okay, so guys, good morning everyone. This is Kumar Ravi, and please, just if you are watching this lecture live, then please do like this session, and let's move ahead. Okay, so in case of current electricity, there are some important things, there are some important topics, there are some important formula that has to be remembered by you. And let us discuss some important questions. Just like when, just like someone asks you that this is a wire. Suppose that I'm just telling you the type of questions asked in examination, actually. So suppose that this is a conductor and this is a conductor, and suppose that 40 coulomb charge, 40 coulomb of charge enters into at this end and enters at this end in time, and the time taken is, this is equal to 0.4 second, sorry, 0.8 second, 0.8 second. It means it takes 8 second time to enter into the wire. Okay, so 4 coulombs of charge. Now you will have to tell me the value of electric current that will flow in the conductor. Okay, so this is the first question. Suppose that there is one concept, law of conservation of charge. Guys, if it takes 40 coulomb, if it takes 8 seconds to enter the total charge, and that is the 40 coulomb, then obviously the same amount of charge will be going outward, out of this conductor, because in this piece, in this metallic piece, in this piece of conductor, the number of particles will remain same. Number of particles means number of atoms will remain same. Number of electron, proton, neutrons will remain same. And hence, if some electrons are entered from this end, or if some electrons are entered from this side, then obviously the same number of electrons will leave this side. Okay, and this is the reason that if 40 coulomb charge enters at one end, then the 40 coulomb charge will leave the other end also. Okay, so the value of current will be flowing electric current. Okay, so current and I, and this will be equal to charge upon time. Charge upon time. Okay, so this is I equal to 40 coulomb, and this is 40 coulomb. Okay, so this is 40 coulomb. This is 40 coulomb actually. Okay, so this is 40 coulomb upon 8 seconds. And this is 8 5 ja 40. Okay, so I is equals to this is equal to 5 coulombs per second. 5 coulombs per second. 5 coulombs per second means 5 ampere. 5 coulombs per second means 5 ampere. Okay, so this is the value of the current that has been calculated from this. Okay, so guys, if you are watching this session, then please do like. Guys, if you are watching this session, then please do like this session. Okay, yes, so this is the first question actually, and the second question is suppose that this is a conductor. Suppose that this is a conductor like this. Okay, suppose that this is a conductor like this, and there are two terminals like this, and these two terminals are connected to a battery, and this one is connected to positive terminal, and this one is connected to the negative terminal. Okay, So if suppose that the potential difference between these 2 points is the potential difference between these 2 points is the potential difference between these 2 points is okay 100 volt. Suppose that the potential difference between these 2 points is 100 volts, 100 volts, and if the resistance of this conductor is 25 ohms, 25 ohms. Okay, now if I want to know the value of the current that will flow in this conductor, then what will be the value of the conductor, what will be the value of the electric current that will flow in this conductor? Okay, so that will flow in this conductor. Now tell me, what will be the value of electric current? So if these two terminals are connected to the battery and the battery voltage is given as 100 volt and the resistance value is 25 ohms, then obviously we all know that the relation between the voltage and the voltage V is equal to given 100 volt. This is the potential difference, 100 volt. ठीक है. And the resistance that is equal to resistance, this is equal to 25 ohms. Okay, so 25 ohms. Actually this is the symbol of resistance. Okay, so this is the symbol of resistance, and I is the value of electric current. Okay, so I is the value of electric current. Okay, so now the value of electric current, that is equal to V upon R. Actually we all know that the relation by using Ohm's law. We all know that Ohm's law is by using Ohm's law. Most of the students, they just know the Ohm's law is given by V is equal to R into I. The students know the value, know the formula V is equal to R into I, and this is commonly known as the Ohm's law. Okay, it means this is the potential difference between the two terminals of the conductor, and this is the resistance of the conductor. Then the current I will be flowing through this conductor. Okay, so here the I will be equal to V upon R. It means this is, if this is 100 volt, then the resistance will be equal to 25 ohms. Okay, 25 ohms. 25 and 5, and this is 4. Okay, so I will be equal to 4 ampere. I will be equal to 4 ampere. I will be equal to 4 ampere. Okay, so this is the value of the electric current that is coming from this question actually. Okay, so this is the way that how does the questions are solved. How do the questions are solved? Yes, please note down, and if you have any doubt, then please let me know. Okay, if you have any doubt, then please let me know. Okay, so guys, these are the two questions. Okay, now let's move ahead. So now let's move ahead, and another question is given by suppose that question number 3. Suppose that the question number 3. Hello. Yes. Question number 3. Question number 3. Suppose that this is a resistance. This is a resistance, and this is another resistance, and this is another resistance. Okay. And suppose that a resistance is connected to the parallel of these two resistances. Okay. And suppose that this is 4 ohms and this is 2 ohms and this is 2 ohms and this is 4 ohms. Okay. Now please calculate the value of A and B. Calculate the value of A and B. Okay. Calculate the value of A and B. Okay. So these are the value of the resistances. These are the value of the resistances. Okay. And now you can just tell me what is the net resistance. I mean the total resistance across A and B. So calculate the value of RAB. Calculate the value of RAB. Okay, that has to be calculated. So first of all, when we see such type of questions, first of all, observe such type of questions first of all, and then you can see here, that these two resistances are in series. Okay, then these two resistances are in series, then it means we can easily calculate the net resistance of the instead of these two resistances. Okay, so the circuit becomes like this. Okay, so we must do the one thing, that we must replace that 2 ohms resistor by a one resistor having the value 4 ohms. Okay, so this one is like this. So this is the 4 ohms resistor, 4 ohm. Okay, now suppose that if we can see that this is a 4 ohm registration, 4 ohm resistor. Okay, then these two resistances are in parallel. Then obviously we will replace this combination by one resistor having the equivalent value of this. Okay, so the circuit will become like this. Okay, circuit will become like this, and this value will become equal to, and this circuit will this circuit will become equal to like this. Okay, the net resistance will become 2 ohms, and now we can see that these two resistors are in series, and so the net resistance will be 4 plus 2, and this will be equal to 6 ohms. Okay, so this will be equal to 6 ohm, and this will be okay, and this will be okay, so this will be A and B. Okay, so this will be A and B. So guys, first of all, you should know that these two resistances are in series. Okay, suppose that the effective resistance is R1. Okay, then the value of R1 will be equal to 2 plus 2, and this will be equal to 4 ohms. Okay, now the equivalent resistance of these two will be equal to R2, and these two are parallel. Then obviously 1 upon R2, and this will be equal to 1 upon 4 plus 1 upon 4. Okay, then 1 upon R2, and this will be equal to 2 upon 4, and this will be equal to 1 upon 2. Okay, so R2 will be equal to 2 ohms. R2 will be equal to 2 ohms. R2 will be equal to 2 2 ohms. Okay, and now the net resistance for this will be equal to R3, and this R3 will be equal to 4 plus 2, and this will be equal to 6 ohms, and this will be equal to 6 ohms. Okay, so this will be equal to 6 ohms. So now this will be equal to 6 ohms. Okay, so such type of questions are solved like this. Such type of questions are solved like this. And suppose that we should move on the next question. Please do note all these things, because these are the very good things, and these questions, such type of questions are asked in different examinations actually. Okay, such type of questions are asked in different examinations actually. Yes, such type of questions are asked in different examinations. Okay, now we will move to question number 4. We will move to question number 4. Okay, and suppose that when we talk about the question number 4, suppose that when we talk about the question number 4, yes, suppose that this is a resistance. Okay, and there is one resistance like this. Okay, and there is okay, there is a nude wire like this. Okay, now calculate the resistance between A and B. Calculate the resistance between A and B. Calculate the resistance between A and B. Okay, calculate the resistance between A and B. So this is B. Okay, and this one is okay, so this one is 4 ohms, and this is 2 ohms, and this is 2 ohms, and this is 2 ohms. Okay, now calculate the value of the resistance between A and B. This is a very good question actually. You will have to keep in mind one thing. You will have to keep in mind one thing, that how can you calculate the value of the resistance. Just see, this point and this point will have the same potential. This point and this point will have the same potential. Okay, so we will give this point as number y1, and this point number y2, and this point number, again this is 1, because point 1 and point 2 are connected by a nude wire. When any 2 points in any circuit are connected by the nude wire, it means they are same points. It means they are same points. Okay, it means they are same points. Now again, this is point number 3. This is point number 3. So guys, we must draw all these 3 points like this. This is point number 1, this is point number 2, and this is point number 3. Okay, so these are 3 points. So these are 3 points actually, like this. Okay, so these are the 3 points. So 1 to 2 actually, 1 and this is 2, sorry, and this is 2 and this is 3. Okay, so 1 to 2, there should be a 4 ohm resistance like this. This is a 4 ohm resistance. There should be 2 ohm resistance between 2 and 1, and 2 ohm resistance between 2 and 1, and this should be like this. Okay, this should be like this, and this is 4 ohms resistance, and this is 2 ohm resistance. This is 2 ohm resistance, and now the 1 to 3, yes, 1 to 3, there should be 2 ohm resistance. 1 2 3 there should be 2 ohm resistances. Okay, 1 2 3 1 2 1 2 3 there should be 3 ohms resistance. Okay, then obviously the 3 is connected to the point number B, and 1 is connected to the point number, and 1 is connected to the point number A. Point number A. Okay, so now tell me, what is the resistance between A and B? If we talk about the resistance between A and B, then how will you calculate? This is a very good question. You will have to observe the one thing, that these two are in 6 ohm. Okay, sorry, these two resistances are in series manner. Okay, so these two are in series manner, then obviously we can remove them like this, and we can just calculate, we can just make one resistance like this. Okay, and this is 6 ohms. Okay, now so this is, now guys, you can see that the current will go like this. Okay, so guys, always remember one thing, that the resistance calculated must offer the whole current of the circuit. Okay, so this is this will be the path of the current, because this will be the path of the current, because 2 ohms, because here we want to conduct the electricity, we want to conduct the electric current from A to B, okay, A to B. Then obviously current will not go like this, that here it will go and then it will go like this. No, current will follow this pink color path, and hence the resistance on the pink color path, that will be equal to 2 ohms, and hence the answer will be equal to 2 ohms, and this will be the correct answer. Okay, we can also observe the same thing from here also, and here also we can see that the current, this current will follow this path, and then it will have two paths, number one and this path, this path, and the another is this path. Okay, so the current will follow the only path number one, because the path number one has the lowest resistance, always remember, current always follow the less resistance path. Okay, current always follow less resistance path, always remember, current always follow less resistance path. Okay, current always follow less resistance path. Okay, so this is the question number 4 now, and suppose that question number 5, you have been given a VI graph of a conductor. This is V and this is I. Okay, this is V and this is I. Yes, you have been given a VI graph of a conductor. Suppose that yes, suppose that this is a graph. This is the relation between okay, so this is the relation between V and I. This is the relation between V and I, and suppose that these are the points, and yes, these are the point like this, and suppose that 10 ampere current, 10 ampere current flows when 10 ampere current flows when a 200 volt potential is given. Okay, now calculate the resistance of the conductor for which this experiment was done. Calculate the resistance of the conductor for which the such experiment was done. Okay, for which such experiment was done. such experiment was done like this. So this is the conductor and this is the plus and this is the minus. Okay, and now the calculate the value of resistance R. Okay, so guys, this is the VI characteristic. This is the VI characteristic. If we go to see that what the Ohm's law says, then we comes out to at the conclusion that it is V is equal to R into I. Okay, so this is actually Ohm's law. So here we can say that V upon I, and this is equal to R, and this can be this is equal to R. Okay, it means the resistance of the conductor. It means the resistance of the conductor. Okay, so this is the resistance of the conductor. Okay, is it okay to all of you? Is it clear to all of you? This is the resistance of the conductor. Okay, now so this is the resistance of the conductor. So guys, here we can say that if we calculate this is V and this is I, suppose that, and this is I, and this is I, then obviously V upon I, that will be equal to tan theta. So here tan theta will be equal to V upon I, and this will be equal to R. Okay, so the slope of VI graph of a graph of a conductor, that actually gives the resistance, and that is equal to 200, and that is equal to 200 upon 10, and that is comes out to be equal to 20 ohms. Okay, so this is the resistance of the conductor. So this is the resistance of the conductor. Okay, so always remember such type of questions are asked. Okay, and suppose that if I ask that if I ask about the question number 6, yes, question number 6 is very good question actually. Question number 6 is very good question actually. Yes. So question number 6 is very good question actually. Question number 6, according to the question number 6, if there is a heater, suppose that there is a heater like this. Okay, so this is a heater, and the resistance of this heater is, we all know that the heating coils are made of nichrome. Okay, so heating coils, we all know that the heating coils are made of nichrome, and nichrome has very high resistance. Heating coils are made of nichrome. Okay, nichrome possesses very high resistance. Nichrome possesses very high resistance. Okay, nichrome possesses very high resistance. Okay, so suppose that the resistance of this coil is capital R, and suppose that if a current is provided of 2 ampere for t is equal to 1 hour. Okay, for t is equal to 1 hour, and the rate of electricity is, okay, rate of electricity is मतलब price rate means price rate is of rupees 4 per unit. Rupees 4, no, it should be 8 rupees per unit. 8 rupees per unit. Calculate the electricity bill. Calculate the electricity bill generated in one day. So what will be the correct answer? What will be the correct answer? So what will be the correct answer? Please tell me. What will be the correct answer? Okay. So guys, here you can see that if we talk about the heater, then obviously the heating current. First of all, we should know that R is equal to, yes, R is equal to, given R is equal to 500 ohms. Okay, 500 ohms. This resistance of the heater is 500. तो हम लोग लिखेंगे यहाँ पर, we will write it as heat generated is equal to the electrical energy consumed. Yes, heat generated by heater that will be equal to the electrical energy consumed. Electrical energy consumed. Okay, so heat generated will be equal to the electrical energy consumed. Okay, heat generated will be equal to the electrical energy consumed. Heat energy that will be equal to I square R into T. I square R into T, and that is equal to I square. I square means 2 ampere. I means 2 ampere. That is 2 ampere into R. R means 500 into T. T means 1 hour. Yes, 1 hour. Okay, and this is equal to 4, and this is equal to 500. Okay, and this is equal to 1 hour. Okay, now we can calculate it as 2000. This is ampere square ohm into R. Okay, so this is this will be equal to 2000 multiplied by, and this is 3600 seconds. Okay, this is 3600 seconds. Then obviously okay, then obviously the correct answer will be equal to, and this will be equal to 3600 seconds. Okay, 3600 seconds. Okay, now so this is the amount of joules. Okay, so this is the amount of heat generated by this heater. Okay, so number of units, number of electrical energy units, number of units consumed, and that will be equal to 2000 multiplied by 3600 upon, okay, in one day. Okay, in one day means 24 hours. In one day means 24 hours. Okay, it means 24 will also be, 24 will also be multiplied by here. Okay, so here 24 in one day, 24 hours. Okay, 24 hours. This is the 24 hours, and this is the number of seconds. Okay, so here total it will be multiplied by 24 hours. Okay, so this will be multiplied by 24 hours, and we all know that the 36 multiplied by 100 multiplied by 1000, and this is the number of joules per unit. Okay, and now actually 36 lakh joule, 1 unit of electrical energy is equal to 36 lakhs joules, 36 lakhs joules, and hence we can easily say that this is cancelled by these two zeros, and now this 3000 will be cancelled by this, and this 36 by calculator by cancelled by this. Now 24 into 2, and this will be equal to 48 units. 48 units. So bill will be equal to, and the electricity bill will be equal to 48 multiplied by 8, and this will be equal to 8 8 64 6 8 चौक 32 32 6 38. Okay, so this is 384 rupees. Yes, so this will be equal to 384 rupees. So guys, such type of questions are asked in CPO examination, SSC CPO, okay, and UPSC CDS and SSC CHSL. So these are the very good questions. You can note it down, and if you have any doubt, then you can raise your query in comment box. In comment box, yes. Okay. So guys, okay, I think everything is clear to all of you. Now we will move to another question, and this question is very simple actually, and this question is very simple. And suppose that if I ask you the calculate the number of electrons passed, calculate the number of electrons entered into the conductor in 1 minute if the 2 ampere current is flowing. Okay, calculate calculate the number of electrons entering, calculate the number of electrons entering at one end, at one end of wire if 2 ampere current is flowing. If 2 ampere current is flowing in wire. Okay, if 2 ampere current is flowing in wire. So this is a wire. Okay, so this is a wire and the 2 ampere current is flowing, and this is wire and 2 ampere current is flowing in this conductor. Now, and suppose that you will have to, yes, now you will have to find out, the number of electrons entering at 1 second. Okay, if the current is flowing in this direction, then obviously the electrons will enter at this end. Okay, so guys, we all know that I is equal to Q upon T. Actually, charge Q is always quantized and hence can be written as the N into E upon T. Okay, so actually when we talk about the 2 ampere current, then obviously 2 ampere, and this is number of electrons entering at one end. This is the charge of electron 1.6 into 10 to the power minus 19, and this is the time. Okay, this is the time actually, and the time is 1 second, because when we talk about the current, it means the current. Then obviously the total, if we first of all we will calculate the charge entering at 1 second, charge entering at one end in 1 second. Then obviously the number of electrons, that will be equal to 2 upon 1.6, 2 upon 1.6 into 10 to the power 19. Okay, so these are the electrons in 1 second. Okay, in 1 second, in 1 second. If we talk about the electrons, if we talk about the number of electrons in 2 seconds, in in 60 seconds, then obviously this will be equal to 2 upon 1.6, 2 upon 1.6 multiplied by 10 to the power 19, 10 to the power 19 into 60 into 60. Okay, so this will be the correct answer. 2 upon 1.6 into 10 to the power 19 into 60. So this will be the correct answer. Okay, so this will be the correct answer. So this will be the number of electrons entering at one end, and 1 minute. Okay, so in this way we calculate the such type of questions, and these are very important questions. As I have already told you that for SSC CHSL, SSC CPO, and UPSC CDS. Okay, and as well as you can study them for Indian Railways exams also. Okay, so guys, this is for today, and tomorrow we will have another session. And we will study some more questions. Okay, and please do like this session and subscribe this channel, subscribe this YouTube channel if you have not subscribed till now. Okay, so okay, any doubt, any comment? If you have any doubt, then you can raise your query here and I will try to solve it out. Okay. Okay, so thank you so much for today's session, and yes guys, if you have any doubt, then please tell me. If you have any doubt, then please tell me. I will try to solve it out as soon as possible. Guys, as I have already told you that you have to download the application. Please download the application so that you can just get updated by the current affairs, free classes, free current affairs classes, free study material. There are some free batches also. You can just watch on the application. Okay, so okay, let's finish this session today, and thank you so much. Have a nice day. Bye bye.